Hi everybody, let's do a little, this is Mr. Folly, and let's do a little bit of, let's do a little bit of shifting equilibrium. Yay! Okay, so, I forgot I'm going to have writing questions here. For the following situations, determine the direction of the reaction will shift. To reestablish equilibrium, explain the shift in terms of Q or K. Determine what the reactions will be, reactions products. Okay. So looking right here, if I decrease the pressure of O2, I'm going to remove O2. So that will shift forward. Explanation based on Q and K. So products decrease. So Q decreases. So shift right to reestablish equilibrium. I can put that in bold. Control, bold. Increase concentration of products. Oops. Of products. I'll just do this. All right. Increase mass of BaO2. This one's going to be no shift. Why solids are not in the Q expression, thus don't affect equilibrium. So no increase. Decrease in temperature. Okay, so on this one, we've got delta H is positive, so I'm going to type the word heat on the left. Okay. So if you decrease temperature, it will shift to the reverse side. Why? Decreasing temperature in an endothermic reaction lowers K, so Q becomes greater than K. If Q is greater than K, is that right? So if it lowers K, then Q will be too big. Yeah. Q will be bigger than K, so I have too many products. So shift left-hand side to re-establish equilibrium. So if I'm shifting left, the reactants will increase. All right, increase the size of the container. So what that does is it gives us more room for gases. So, excuse me, that'll shift forward. So a larger volume lowers the molarity of gases. Oh, I guess there's only one gas. So Q goes down and shifts right-hand side to re-establish. I'll get to spell it. Okay. Oh, so if that happens, my products will increase. Let us say increase sometimes. Oh, increase concentration, pressure. Okay, that'll work. Now, if it says concentration or pressure of the reactants, technically, I could say here the pressure and concentration doesn't change for BaO. So let me do this. Oh, no. Get my little... Oh, no, so because this is only a solid, the pressure or concentration will never change. So really the answer is no increase. But here they increase in mass, not pressure or amount. Okay. So the reactants increase in mass. So either one of those I would take because the question's got a little bit of a flaw. Here we go, same thing. Decrease the size of the container. Remember, decreasing the size of the container will shift to the side with fewer moles of gas. So I have 3 moles of gas on the left I have 2 moles of gas on the right, so it will shift forward. Control bold. Explanation of Q and K, Control B. Decreasing volume would increase molarity of gases. Yeah. Decrease says, I'm sorry. My explanation's right, but I think I said the wrong thing. Decreasing the size shifts to the side with fewer moles of gas. Oh, so that is right. Forward has 2, reverse has 3. My bad. Would increase the moles of gases. Would increase reactants more than products, and Q goes down. The shift is forward to re-establish K. Oops. I'm going to see if we can remember to copy and paste my to re-establish K. So if I'm shifting forward, my products will increase. Increase in concentration of O2. It's going to shift away from the O2. That'll be forward. So concentration of O2 increasing. So as products over reactants decreases K. So I would have too many products. So shift products over reactants. I'm sorry. Concentration of I'll put K instead of Q. Concentration of O2 products over reactants decreases Q. So shift to the right hand side. Increase the concentration of O2 does not shift to the forward reaction. Oh yeah, it does. So, sorry, my mind is slipping today. So what I have is Q equals P over R. I've increased my reactants, so Q goes down. And if Q is too small, I need to shift forward to increase P. So shift the right hand side to reestablish K. So if I'm shifting forward, my products will increase. Decrease temperature. Oh, so delta H is negative. So what that means is I'll put plus heat, heat on the right-hand side. If I decrease temperature, it will shift to the forward direction. Control bold. And then control bold. Increasing temperature on an exothermic reaction increases K, so Q is too small, and reaction shifts to the right-hand side to reestablish K. Shift to the right-hand side, my products are increasing, booyah. Using a catalyst, none. Control both reactions speed up equally. No increase. Boom. Experimental increase in temperature always favors the endothermic reaction. The added energy impacts the endothermic reaction more as it has a lower EA. Oh, has a higher EA. So if I were to draw this exothermic, essentially the same thing. Okay, so if it has a higher EA, that added energy, those elite energy things are a lot harder to get to. So, what effect does an increase in temperature have on the size of K for an endothermic reaction? So if I increase an endothermic reaction, it will increase K. exothermic reaction, decrease K. That's it. And we are done with part 3. Two toodles.